Hello everyone, I am Rashtra Ashilkar, Secretary at ISF Asset, and in this session we are going to build a 3D animation with planet Saturn and its moon Titan revolving around it. And for this we are going to use JavaScript's library 3.js. So let's get started. For this project I have created three files. First, index.html, where I have passed the main Saturn.js JavaScript file. The other one is the actual JavaScript file where the main logic is written, and the third one is app.js, in which I have used express.js, a JavaScript framework for local hosting. Okay, so first we will import the main 3JS module and orbit controls module. So the orbit controls module will help us to have control over mouse movements on our screen. In a 3D world, what we need basic things are a camera and a renderer, which will render all the scenes that we can see on the screen, and scenes to add the objects that we want to see on our screen. Okay, so I have used perspective camera, the first element being the field of view. The next parameter that I have passed is actually aspect ratio. The third is near clipping plane, and fourth one is far clipping plane. And I have set up the camera at a particular coordinates. You can play with these coordinates and put the camera wherever you want. Next, I have declared the scene variable and renderer, WebGL fix library, and anti-alias is true so that we do not get rugged images, but a rather a smooth edge. Okay, and the next thing is we need light, right? So I have used ambient light, which will not let the darker areas become more black, but will keep them as if they are in shadow. And point light will act as a source of light, more like a torch. The first parameter in both of these cases is the color of the light. The second is intensity, and for point light the third one is the distance uh, which we have to pass. Okay, and also I have set up the lights at particular coordinates. You can also play with this. The main thing is, after setting lights, we have to add those light in our scene. So I have added lights to our scene, and also point light. We are going to use this point light to on our planet Saturn, right? So it should cast some shadow. So I have kept this as true. Okay, so let's come to the main function. I have created a function in it which I will uncomment now. We'll see what the first thing is. So I have used renderer.setSize. What it will do is, according to the screen size, it will set up the canvas for the 3D scene. Okay, and the orbit controls is, as I said earlier, would help me to have control over the things that I see on the screen using my mouse. The next four lines will come to these in a few moments. Let's see how we can create a sphere for the Saturn. Okay, so for the geometry part I have used sphere geometry, with the first parameter being the radius, and the next two are the width segments and the height segment. The next is texture. For the texture I have downloaded Saturn's image and loaded it using 3.js's texture loader method, and loaded it into my variable texture. The material will take the texture and map it using mesh. Okay, but the material that I have used is Lambert material, which is ideal for simulating objects more of a sturdy stone or rugged rough surfaces. You can also use Phong material, which is ideal for glassy surfaces. Next, for the Saturn, what I have done is I have rotated the Saturn on world axis, on the z coordinate, on the z axis, with some angle, which is actually which I have googled is the angle of tilt for the Saturn's axis, and added the Saturn's object. Okay, so let's see what happens when I run this code. Of course, definitely nothing is going to happen because we haven't set up yet the animation function. So what I have done here is I have created another function. I will comment these lines for now. And okay, so let's call the animate function and the init function. I will save it and run it on my local server. So as you can see, there's a sphere with the Saturn's texture, a ring at a particular tilted angle, and the moon too. Well, we'll come to the moon part. But as you can see, I can control the movements of the planet with my mouse. So which is actually what the control lines is doing. Okay, this actually the this line, and the minimum distance and the maximum distance is 60 and 200. So I cannot zoom out more than a particular distance or less than a particular distance. Okay, and the polar angle that I have set is pi by 2 degrees, so I cannot rotate it vertically. It is stuck only in the horizontal rotations. Okay, so we'll see how I have created the ring. For this, I have used ring geometry, with the first parameter being the inner radius, the second parameter is the outer radius, and the third parameter is just like the sphere's parameter, which is smoothness. So you can actually set it up according to your need, which you will see if you play with it. It will make it more smooth or more edgy. The next is the texture. I have downloaded an image ring, just the image that you can see here, image of the rings, which I have loaded using the texture loader. And the material here also is Lambert material, but here I have set up the side as double side, so image will be pasted on both sides of the ring and not just one. Otherwise it will just be black. If I show it here, okay, I'll do just back side, and we'll see what happens when I do that. So as you can see, if I rotate it more, the image won't be seen, because the image is pasted just on one side and the other side is completely invisible. So I will change it here again to double side, and the mesh will do the mesh will combine both the geometry and material. Here on the rotate world axis, I have rotated the ring also with some angle, which I have also googled is not so accurate, but it is fine. I guess that is the angle of tilt for it. And the moon part, okay, so the moon, just like Saturn, will be spawned at the origin part, right? But we need it to be at a particular distance from the Saturn. So what I have done here is translated the moon on the y-axis at some particular distance. Here I have passed 14 units, and also on the z-axis with some units. Okay, so because in Three.js the z-axis is the one which is coming towards us, the x-axis is the one which is going to right, and the y-axis is the vertical axis. So that is why I have used y and z-axis, so the moon can be set at this particular coordinates. I have added the moon in this line. This line is actually more important, because you create a scene, but you want that scene to be attached to your index.html, right? And which cannot be seen if the renderer is not present in your HTML file. So I have appended the renderer's element to the body of my main document. Now you must be wondering why we have created this animate function. So the renderer.render will take the parameter scene and camera and set up our 3D screen, and the request animation frame will take the same function animate and keep on updating the scenes with 60 frames per second. And the important part about the request animation frame is that if I change the tab, the scene won't be rendered, thus saving your CPU's power. So let us see what the animate function does. The first line is actually an event listener, which will reload the current tab if there is a resize. So every time when I change the size of the tab, the location of the current tab will be passed and it will reload itself. So this is what this event listener does. To give rotation to the sphere and the ring, I have used to rotate on world axis. So actually there are two axes, the one which is world axis and the other which is local axis. Because we don't want to have the rotation in the local axes, so I have used this method of rotation on world axis, where the first parameter is the axis around which I want the rotation, which is obviously the y-axis, which is vertical, and the another parameter is the value by which I want the rotation. So you can play with this value and have the change in the rotation speeds. The next thing is rings rotation. Because the ring should also be rotating, here I have not used the world axis, because I want the ring to rotate in its local axes around z axis, right? Okay. Coming to the moon part, what I have done here is declared and defined three variables: r being the radius of the radius around which the moon will be revolving. Theta is the angle which I will explain, and d theta is also the small angle by which theta should be incremented, right? So, or decremented, because you can increment or decrement depending whether you want clockwise or anti-clockwise revolutions. So I have done the decrement operation here. Because the moon is in x and z plane, so I have used polar to Cartesian coordinate system here, and used circles polar coordinates to convert them into Cartesian coordinates of x and z, and uh, I am also rotating the moon in its local axis only. With this value will actually set the speed of the rotation. And also b is I forgot to uncomment it, so b is defined here, so you have to declare it. And that was it. That is all you need to make 3D animation using 3.js. I hope it was helpful. You can check the description box for more information on this. I will put my GitHub link in the description, and don't forget to like, share and subscribe our channel. Goodbye.